This is what a trigonometric table looks like. This is actually a copy of the one in the back of your book. Now, we don't really use trig tables anymore because we have calculators, but they do provide us a little bit of understanding of the way that trig functions work. So I'm going to start by having you look at this 3-degree angle. We're going to look all the way across the row. So you can see the first column is degrees, the second column is radians. We're not bothering with radians right now. But then we have sine, cosine, tangent, cotangent, secant, cosecant. If you look down at the bottom, you'll see that the next column is also radians, and you see that degrees is written at the bottom. You can also see that trig functions are also written at the bottom. The way that these work, if I want to know the sine of a 3-degree angle, I can look across to where it says sine, the cosine of 3 degrees, the tangent of 3 degrees. The important thing is that the complement of 3 is 87. If I start looking backwards, I'm going to be looking at co-functions. So the sine of 87 will be the same as the cosine of 3. The tangent of 87 is the same as the cotangent of 3. That's something that we actually talked about in the last section. And this works for all values. This table, like I said, is in the back of your book on page 814. When you're using your calculator to calculate any trig functions, the first thing you have to do is make sure that you are in degree mode. To do that, you're going to push the button that says mode, and this is what your screen will look like. You're going to arrow down to radian and then over to degree, and you'll hit enter on degree so that it's highlighted. Once you've done that, you hit second mode, and that will exit you out of that operation. For most of what we're going to do, it will be very, very simple. Once you are in degree mode, that's all you have to do. So if you're going to put these into your calculator in degree mode, cosine of 32.5 is pretty simple. You will just push the cosine button. It will show you a parenthesis. You'll type in 32.5, close the parenthesis, and you'll hit enter. And it will give you the answer of 0.8434. You should show at the very least 3 decimal places. If you refer to that table, you'll see that even going out to 4 decimal places, it doesn't give you a lot of differentiation among angles that are to 1/10 of a degree. When you're looking at a problem that's more like this, where you're in degrees and minutes, it's still pretty simple. You'll hit the sine key, the parenthesis will show up. Here you'll have to put in the 78 degrees and 10 minutes. The way that you do that is you will hit second apps. Option 1 is the degree symbol. Option 2 is the minute symbol. That's what you'll use to enter this information into your calculator. Once you have done that, you'll see that your answer is 0.4730. Again, 3 decimal places will suffice. For this example, we're looking at all 6 trig functions of this given angle. The first 3 are going to be really simple. You'll plug into your calculator sine of 28 degrees, 14 minutes. You'll hit enter, and you will get 0.4731. For the next one, you'll type in cosine, 28 degrees, 14 minutes, and you'll get 0.8810. You'll type in the tangent, and you get 0.5369. Things are going to get trickier when we look at cosecant, secant, and cotangent, because we don't have keys for that on the calculator. So for cosecant, remember that the cosecant is just the reciprocal of sine. So what you can put into your calculator is 1 over the sine of 28 degrees, 14 minutes. When you do that, you get 2.1139. The secant you'll do 1 over the cosine of your angle. And you'll get 1.350. And finally, the cotangent. You'll take 1 over the cosine, 1 over the tangent, to get 1.8624. As I said, the first three are really simple. You'll just put them directly into your calculator. These next three are quite a bit of a challenge because you need to remember that we're looking for the reciprocal. This next question uses a technique that I call untrigging. Right now, we're looking for the measure of an acute angle given that we know the cosine. We already know the ratio. So we need to untrig this in order to find the value of the angle. The way we do that is by using the inverse cosine. So what you'll type into your calculator is this. In order to get this to show up, you'll need to push the button second, then the cosine button. This is actually different than the reciprocal. This is the inverse, meaning it's the opposite operation. When you've put this into your calculator, you'll get an answer of 33.592. Because we actually are finding an angle theta, this is a degree. It's okay with me if you leave this as a decimal. If you prefer to convert this to degrees, minutes, seconds, then you'll hit the second apps, and you'll go to option 4, which is DMS, which stands for degrees, minutes, seconds. If you do that, you'll get 33 degrees, 35 minutes, 30.641 seconds. We're doing this again where we're looking at all 6 trig functions of the angle. This time it's given in decimal degrees. Again, the first 3 are easy. think about the fact that this angle, being 132.4 degrees, is in quadrant 2. So if we're thinking about all students take calculus, quadrant 2 sign is positive, the rest are negative, so these are correct. For the other three trig functions, remember we're going to have to take the reciprocal. So cosecant means that what I'll put into my calculator is 1 divided by the sine of 132.4. Secant means 1 over the cosine of 132.4. And cotangent means I'll take 1 over the tangent. Again, your answers should make sense. Sine is positive, cosecant should be positive. Cosine is negative, secant should be negative. Tangent is negative, cotangent should be negative. Finally, I'm looking for two angles between 0 and 360 degrees, where if I take the cosine of the angle, I will get 0.7540. So the first thing that I will do is I will untrig this. So I know that theta will equal the inverse cosine of 0.7540. That gives me an angle of 41.062 degrees. To find the next angle, I'm going to rationalize through this. I'm going to think about my coordinate plane. I'm going to think about all students take calculus. So I know that the other angle has to be in the fourth quadrant. So I could sketch that wherever in the fourth quadrant. Now the angle that I have is 41.062 degrees. What I know is that my reference angle has to also be 41.062 degrees. So now what I'm looking for is an angle that starts on the positive x-axis and rotates all the way through less 41.062 degrees. In order to get that value, I'll take 360 degrees and subtract out 41.062 degrees. That gives me 318.938 degrees. If I plugged into my calculator the cosine of 318.938 degrees, I should get the exact same answer that I would get if I plugged in cosine of 41.062 degrees.